El Dorado High School. We are here today to learn about nth roots, okay, nth roots, and to kind of let you know, kind of tie back to something that we would understand, like if we said x is equal to 2, then if I said what is x times x, what's another way to write x times x?
X squared.
X squared. And if x is 2, then x squared is equal to what? 2 squared is 4. Okay, so we see that. Now, similarly, I could come in and I could say the square root of 4 is equal to what? 2. Okay. Now, since we've only done square roots, we just write the square root. But which root am I taking of 4? The second root. And so really you could think of it like that, the second root of 4. Now, you don't write the 2 because if it's just a square root, it's so common that you just do it like that. Okay. Now, this is the thing to think, though. What if I had x times x times x? That's going to be equal to x what? Cubed. Okay. And then that x cubed, if x was equal to 2, would be what?
8.
8. And you got there by saying 2 times 2 times 2 is equal to 8. So you have 3 2's. 2 times 2 times 2 is 8. Now, because of that, you could also have not the square root, but the what root?
Third.
The third root of 8. Okay. The third root of 8 is 2. Okay. So what you have to see is there's not just a square root. You can have the third root or the fourth root or the fifth root. Okay. So what we want to kind of do is we want to just get comfortable with that idea. So let's look at, we can have the powers. We're going to look at powers. We're going to look at factors. And then we're going to look at roots. Okay. So if I have a cubed is equal to 125, what times what times what would equal 125? What?
Or negative 9 times negative 9 times 9.
9 times 9 times 9 is not 125.
5.
Say it loud.
8 times 8 times.
Oh, wait.
Okay,
My
yeah.
question.
There's two things you could say. A times A times A, right? But it's also what? Somebody said it. 5 times 5 times 5.
Wait, is that an A or a 9 in the first thing?
This is A cubed.
Oh, okay. I thought it was a
Oh, I see. So you guys were getting confused there. All right, so let me write it better. Thank you. I was thinking, what on earth are they talking about? A cubed is equal to 125. That's A times A times A is 125. Or what number would you put in? 5 times 5 times 5. So 5 is what root of 125?
Third.
It's the third. 5 is the third root of 125. Okay? Let's do another one. What if I have, I'll draw my A carefully, a to the fourth is equal to 81. Braden, your way, what would you say?
8 times 8 times 8 times 8.
Yeah. It's equal to 125. Or we could say what times what times what times what is equal to, I'm sorry, 180, I'm sorry, 81. I should have said 81. Okay. What?
3.
3. Because you know 9 times 9 is 81, and 9 is 3 times 3, and 9 is 3 times 3, so I end up with 3 times 3 times 3 times 3 is 81. So I could say 3 is the what root of, and I should have said root here. 3 is the what root of 81? It's the fourth root of 81. It's the fourth root of 81. Okay, so you guys get that idea, right? So generally, how are we going to do this? We're going to do it this way. In general, this is how we do it. Let's say I have the nth root of 50. What do we call this strange symbol here? That's the what? The radical. Okay. Now don't say square root because it's not always a 2 there. Now, if the radical has a 2 there, it's the square root. If the radical doesn't have anything, you assume that it's a what?
Square root.
A 2. And then if it's anything other than 2, you need to put a number there. So this is the index. This is the radical. And then this is the radicand. The radicand. The radicand. Kind of a strange word, radicand. Okay. Now, one of the things, now be careful before you answer this. Okay? Be careful before you answer this. Think. What is the square root of 36?
Plus or minus 6.
Plus or minus 6, yes. Because normally you just blurt out 6, right? But no, it's plus or minus 6. Why is that important? Because minus 6 times minus 6 is equal to what? 36. And you remember when we're factoring and we're doing completing the square and we're doing things like that, we don't find all the roots because we forget when we take the square root, we've got to do what? Plus or minus, and that lets you find all the roots. Okay, so you have to be able to do that. All right, so the principal, like if they ask you for the principal root, that just means take the plus one. And so if you say, what is the principal? I got to see how to principal. Root of 36. That would be plus 6, right? So if it says principal, what it means is it's asking for the positive one. Okay? Now, let me ask you this, okay? Let's think about some of these. What if I have minus the square root of 16 and I want the principal root? That would be what?
4.
Okay, so if I say what is the principal root, what would the answer be? Negative 4. Because the principal root is 4, and then I got a negative out front, so that's negative 4. What if I had the square root of negative 16? Is this the same thing or a different thing? Completely different. I like how you said that. It's not even close because I've got to deal with what?
I.
So how would I do that?
4i.
You're right, but help me help me along. I would split it into what? The square root of negative 1 and the square root of 16. You are not wrong, Logan, but you're still skipping steps. I want you to help me get there. So I break it into this, and then this is what? I times 4. And if I'm doing the principal, then I could just do this. If I wanted all, you could still say this is plus or minus this, right? You would really want to put plus or minus out there. Okay. Now, this is let's see. Let's think about the different cases that we might deal with, okay? We're talking about n, the index. So I have the nth root of something, right? I have the nth root of something. So let's say I want the nth root of b, and b is greater than 0. Okay? And I want the nth root of b, and b is less than 0. And then what if b is equal to 0? Now, what two possibilities can I think about here with n? N could be what or what? Positive or negative, but we're really kind of not talking about that yet. That was a good, I like how you're thinking, but it could be even or odd, okay? Even or odd. And you got to be careful because you think, what happens if I have the square root of negative 16? Is there a real solution? No. So there's no real solution to that, okay? But what if I have the cube root of minus 8? Is there a real solution for that? Negative 2. Okay, so this is what you got to be careful of. Just because you see a negative under a radical, you don't automatically say, oh, no solution or no real solution, right? Because the odd ones, there is a solution, okay? So, if you have the nth root of b, and b is greater than 0, you have one positive and one negative root. One positive real root, one positive or one negative real root, right? One negative real root. All right. If I have the nth root of b and b is less than 0, if it's even, how many real roots do I have?
0.
No real roots. Now I do know that I have a positive and a negative what? Imaginary root. A positive imaginary root and a negative imaginary root. Okay. Now, if I have the nth root of b and b is greater than 0 and n is odd, what do I have?
Positive.
Yeah, same thing. One positive real, one negative real. Okay, so if b is greater than 0, it's like you got two real roots, right? That's very simple. But if b is less than 0, it matters whether you're doing a what or a what. An even or an odd. Okay, here I would have no positive roots, no real positive roots, and one real negative root. Right? So let's think about this one. If I have the cube root of negative 8, how many roots do I have? 1. It's not a plus or minus thing like the even ones. It's 1. It's negative 2, right? 2 doesn't work. Does that make sense? Okay. If b is 0, what do I have? It doesn't matter. 1, and that 1 is 0. 1, and that 1 is 0. Does that make sense? Any root of 0 is always what?
0.
0. Right? So that is pretty straightforward, I hope. Okay? Now, what we got to learn how to do is we've got to learn how to simplify things that are under the radical. And we've done this a little bit before. Okay? And we've got to get better at it because you always, for the rest of your math career, you have to do what to things under the radical? You have to simplify things under the radical. So if I have the square root of 27, can I leave my answer as the square root of 27? No. You have to say that is what times what? The square root of 3 times the square root of 9. And that's equal to the 9 becomes a 3. 3 on the square root of 3. You have to take your perfect squares out of underneath the radical. Okay? Does that make sense? All right. Now I want you to think about this though. How about if I had the square root of 27x to the 5th? Tell me what things I have to worry about now. Well, I have to worry about what and what?
X 27.
27 and the x's. So I'm going to need to do this as the square root of 27 times the square root of what? X to the 5th. Now what do I do with the square root of 27?
Square root of 3 times
Square root of 3 times the square root of 9. What do I do with the x to the 5th? Is that fine like that? No, I can take perfect squares out of that. That is what?
X cubed.
X to the 4th times square root of x, right? So then this becomes 3, the square root of 9 becomes 3 onto the square root of 3. The square root of x to the fourth becomes
X squared.
x squared times the square root of x. Okay. Now, sometimes it's good to go ahead and put those two back together. So this would be equal to 3x squared, the square root of 3x. You see, I've taken everything out. Now, I'm going to show you something that is where you guys are going to mess up if you're not careful. Okay, the cube root of 54x to the 7th. Someone just talk out loud. You don't have to tell me an answer, but just make an observation or talk out loud.
It's the cube root.
Yeah, it's the cube root now. So am I going to be taking out perfect squares? What am I going to have to take out?
Perfect cubes.
Perfect cubes. Do you see that? But we get so used to doing perfect squares, and we're doing perfect squares, perfect squares, perfect squares, and one day a cube root comes along, and what do we accidentally do?
Perfect.
Take out perfect squares, and that would be what?
Wrong.
Okay, so I need to break 54 up into what? Okay, tell me what I break 54 up into.
9.
9 times what?
6.
Is 9 a perfect cube? No. Is 6 a perfect cube?
27 and 2.
27 and 2. Why did we choose 27?
They're perfect cube.
Because it's a perfect cube times the square root of 2. Okay, Levi, tell me what we're going to do with the x to the 7th, or at least talk out loud.
It's going to be x4, x3.
Is x4 a perfect cube?
Well, x3 is a perfect cube.
Okay, but does x4 have a perfect cube still in it? Yeah.
Yeah, so you're going to x cubed plus x cubed, or times x cubed times x.
What would, tell me a more straightforward way. Break it into two things where I take out the biggest perfect cube that I can. Like, because it's a cube, I'm looking for groups of what? 3. What's the biggest group of 3 that I can take out of 7?
6.
Okay, so then that's going to be, ooh, I forgot my cubes there. You guys should have yelled at me, right? You should have yelled at me. Times the cube root of what? X to the 6th times the cube root, how many do I have left? X. All right. So the cube root of 27 is? 3. Can't do anything with 2. Cube root of 2. What's the cube root of x to the 6th?
X cubed.
X what?
Cube squared. X squared.
X squared, Tanner. Mr. Math, Tanner. Had a momentary glitch. X squared, and then I have the cube root of x. Let's lump these things back together. So I have 3x squared, the cube root of 2x. Does that make sense? Is everybody happy with that? Okay. So let's think about this, and you guys have got to remember, be very careful how you answer this, because I will yell at you. What can I do with the square root of a squared plus b squared?
Nothing.
Absolutely nothing. I like your answer, nothing, but I would have liked better. Absolutely nothing. Because when you get in a hurry, what are you going to do?
A squared. You're going to say the square and you're just going to break
You're going to say that it's a plus b. That would be what? Wrong. Right.
it. A times a plus b.
Yeah, it's a times a plus b times b. You can't distribute the radical, right? You can't distribute the radical. So this, there is nothing you can do with it, okay? Well, what would the square root of x squared plus y squared raised to the 8th?
X squared, y squared.
It's what?
X squared plus y squared equals 4.
Yes. This 8 can be dealt with this square root by making it x squared plus y squared raised to the 4th, right? Because this radical, that 2, kind of takes it to the half power, so the 8 becomes a 4. Does that make
So
sense?
then would you distribute that?
Well, how would you distribute what?
Cube.
I don't see a cube there.
Or the 4.
What are you suggesting?
You have to multiply it so it'd be x 8.
Absolutely not. That's what I'm trying to tell you. You guys have got to stop doing that. Does the power distribute? No. What is avocado squared?
Avocado times avocado.
What is guacamole squared? What is x squared plus y squared squared?
X squared plus y squared squared.
X squared
Times
plus y squared.
What are you saying, Levi?
X squared plus y squared times x squared.
Yes. So what is this, Levi? It's like that. X squared plus y squared, x squared plus y squared, x squared plus y squared, x squared plus y squared. And if you want to FOIL that out, it'll take the rest of the class, right? And you're going to have about 27 terms. You can't just say x squared plus y squared to the 4th is x to the 8th plus y to the 8th. You got it?
Yes, sir.
This is the most common mistake that I see you guys make, and you make it over and over and over and over and over and over. X plus y squared is not x squared plus y squared. Okay? Got that? All right, let's move on. Okay, and a really common mistake that I see you guys making is, like, I'm giving you a 5th root and you work it like it was a square root. Okay, I give you a 5th root and you work it like it's a square root. Okay, so tell me what this would be. Or just talk out loud or say something. Make an observation.
So it's the 5th root.
It's the 5th root. And I got to deal with each one of those terms. Which one do you want to deal with first?
32.
Does 32 have a 5th root, or can you take a 5th root out of it? No? Count with me. 2,
2.
4.
8.
Oh, it's 2.
Times
Start again.
2,
4, 8, 16.
Go with me.
2, 4,
Oh, 32
8,
is the
16, 32.
32 is a what?
50. Or 50.
So what is the 5th root of 32?
2.
2.
What is the 5th root of 15? Of x to the 15th? What?
X cubed.
X cubed. What is the 5th root of y to the 20th?
Y to the 4th.
Boom. Right? Does that make sense? Okay. Now there is one crazy rule that you got to know. Okay. Write this down, put a box on it, and star it. Because if you forget to do this on the homework, it's wrong. Okay. When you do these, like you have the nth root of x to the, or let's say, the 8th root of x to the 8th. Okay. This is where you start. This is where you end. Now there's something you have to check for on every single one. If this is even, what does the answer end up to be? What? X. And that's x to the what? 1. If the exponent starts even and ends odd, you have to add absolute values. So this started what?
Even.
And it went what?
Odd.
So what do I have to add to the things that went from even to odd? Okay, so if you start even and go odd, so if I have the square root of x to the 6th, y to the 8th, what does that become?
X cubed, y to the 4th.
X cubed, y to the 4th. What do I need to do?
Absolute value around x.
Absolute value around only the x, right? Absolute value around only the x, not the y, because the y stays. You just don't put absolutes everywhere, but you have to do that. That's a rule. Does that make sense? Don't ask me why it's a rule, but that's the rule. Okay. So let's look at the homework. We are on Chapter 7, Section 4. Chapter 7, Section 4. Homework is 13 through 32. The bonus is 68. We are done. Did you cut the live stream, Tanner?